Okay, so what we're going to do is go through the few examples that are in the PowerPoint notes, and I'm going to do them out for you in case you want to see them again. So these are the rules. Remember, the first thing we have to do is determine the total number of valence electrons for all of the atoms in a formula. And at this point, you're just going to consider all those electrons kind of in a pool. They've been pooled together. The atoms are looking for a metal. There are no metals to give them electrons, so instead, they're going to combine all their electrons, and then they're going to divvy them up evenly so everybody gets their octet. No more this is yours, that's mine, I need 2, but you need 3. Now it's just put them all together in one big pool, and then we'll divvy them up so everybody's happy. The next step, number 2, is choose a central atom. Never hydrogen, and it's usually carbon. When in doubt, put carbon there. Usually carbon. Okay. The third step, once you figure out what your central atom is, you're going to connect all the other atoms to the central one with single bonds. Remember, a single bond is just one line. That means 2 electrons. And then you're going to give all the outer atoms an octet. Remember, octet means they need to have 8 unless it's hydrogen, and then hydrogen just needs 1 bond. So hydrogen should only look like this, H with a dash. Never put dots around hydrogens at all. Never do double bonds or triple bonds with hydrogen. Just one line is fine. All right, we'll come back to 5 and 6 when we do some more examples, but we're going to do steps 1, 2, 3, and 4 right now. Figure out the total number of electrons in the pool, pick our center atom, connect them with single bonds, and then give all the outer guys an octet. So here's our first example, CCl4. Carbon has got 4 valence electrons because it's in group 4. Chlorine has got 7, and there's 4 of them, so 7 times 4 is 28, and then we're going to add the 4 and the 28 together, and we get 32 electrons. So 1 carbon and 4 chlorines pool their electrons together. They say to each other, we've got 32 electrons. Let's now divvy them up so everyone's happy. So now the next step, number 2, we got to pick our central atom. There's 1 carbon and 4 chlorines, so the 1 carbon goes in the center. The 4 chlorines go around it, and you connect them all with single bonds. Now this just used 8 electrons, 2 there, 2 there, 2 there, and 2 there. Remember, every bond is 2. So there's 8, so 32 minus 8 leaves us with 24. It's imperative you keep track of your electrons here. Just trust me, do it. So here's 24. Now the next step, step number 4, was to give all your outer guys an octet. Now let's look at this chlorine right here. There. This chlorine's got 2 electrons already. Remember, the 2 electrons are zipping around the chlorine, and then they're going back and zipping around the carbon, and then going back around the chlorine, and going back around the carbon. So for part of the time, it's got 2 electrons, and it's happy about that, but not entirely thrilled, because it needs 8, not just 2. So we're going to fix the problem. We're going to give it 6 more. We have plenty of electrons left in the pool. We have 24 at this point. So we're going to remove 6 from the pool and put them around that chlorine. That gets us to 18. Then we're going to put 6 around this chlorine, and then remove the 6 and record that, so it gets down to 12. Take another 6, put them around this chlorine, and then the final 6 around this chlorine. So now the pool is empty. We've used all our electrons, which you absolutely have to do. So make sure you keep track of your electrons. And then we take a peek, everybody's happy. This chlorine's got 8, it's got 2 in the bond, plus 6 of its own. This chlorine's in the same boat. So is this one and this one. This carbon is happy also, because remember, these 2 electrons zip around the chlorine, but then they come back around the carbon. They go around the chlorine, but then come back, and so forth. So 2, 4, 6, 8, carbon's all set. Everybody's happy, and we end up with this structure. Now, if you look in 3D, this has got 4 atoms bonded. You should use your reference sheet right now. 4 atoms bonded to the central one. The picture that's got 4 atoms bonded to the central one is what we call a tetrahedral. So this is going to be a tetrahedral shape. Next one, NH3. Nitrogen's got 5, hydrogen's got 1, and there's 3 of them, so 1 times 3 is 3, there's 8 electrons. So these guys don't have a whole lot of electrons to pool together, but they have 8. Next thing, figure out who your central atom is going to be. Nitrogen, never hydrogen. Connect all the H's with single bonds, and there's 3 of them because it's NH3. There's 2, 2, 2. There's 6 electrons. 8 minus 6 is 2. I've got 2 electrons left. Now the next step, the 4th step, said give all your outer guys an octet. hydrogen is all set. Remember, hydrogen fills the first energy level with 2 electrons. It doesn't need any more. So this hydrogen's all set with 1 bond, so is this one, so is this one. So we can't give any more electrons to our outer guys. But the next step, number 5, says add any remaining electrons to the central atom. So we're going to look in the pool and ask, are there remaining electrons? And there are, 2. And we're going to put them right here, because little nitrogen only had 2, 4, 6. It wasn't happy. Now it got 7, 8. So now everybody's happy. Hydrogens are all set. And the nitrogens are all set. 2, 4, 6, and then 8 over here. Now this structure, if you look on your reference sheet, is going to look like this. It's going to be basically a pyramid. It's got 3 atoms bonded to the central one, so it's trigonal. And then it's pyramidal, because it sits up like a pyramid. Remember, these 2 electrons here make a big difference. They push these electron clouds away from this negative region up top, and they end up forming this pyramid shape. And Br3 I'm going to skip because it ends up just like the NH3. It ends up looking like this with 6 electrons around this one, 6 electrons around this one, and, oops, ignore that. Let me see if I can erase that. Okay, and 6 electrons around this one, and then there's going to be 2 left over, and they go up there. So try it out if you want. This is also going to be trigonal pyramidal. All right, SO2. It's getting interesting. We got sulfur with 6, oxygen with 6 times 2. There's 12, 18 electrons. Put sulfur in the middle, connect the oxygens with single bonds. So I don't know what happened there. Subtract 4. So now we're at 14 electrons left. Give the outer guys an octet. 1, 2, 3, 4, 5, 6. 14 now becomes 8. 1, 2, 3, 4, 5, 6. Now it becomes 2. 8 minus 6 is 2. Now we've got 2 electrons left. Now I said before, you put them on the center atom. Now this center atom has 2 and 2. It needs 4 more. So it looks in the bank and says, are there 4 for me? And the answer is no, there's only 2. So we put the 2 on the sulfur. Bank is empty. There's nothing left. We have to know that, so keep track of your electrons. Now the little sulfur looks and says, I have 6, I need 8. The last step, number 6, is going to be rearrange unshared. Remember, these are just little dots all by themselves. Unshared pairs of electrons so that the center atom has an octet while the outer guys still have the octet. So this is what this means. You're going to take one of these sets, eeny, meeny, miny, mo. Let's pick this set right here. You're going to cross that off. It's not around this oxygen only anymore. Now it's going to be between the oxygen and the sulfur. So it's going to turn into a double bond. So the little oxygen doesn't have 6 of its own anymore. Now it's going to have 4 of its own, and then share 4. So you could rewrite this nice and neatly, and it's going to look like this on paper. And then if you look at your reference sheet, it actually ends up looking bent. There's your double bond. If you want to draw that, that's fine. And here's your other element. And then there's your 2 electrons. So it ends up with a bent shape. Not linear. The reason is these electrons are negative. They don't like this electron cloud. They don't like this electron cloud. So they actually push them down and away from this negative region up here. So sulfur. Now sulfur's got 6 and oxygen's got 6 times 3, which is 18, plus the 6 is 24 electrons. So we've got 24 electrons. You're going to put sulfur in the middle, connected by 3 oxygens. There's 6 electrons. 6 electrons from 24 leaves us with 18. Give your outer guys an octet. So put 6 here. That brings us down to 12. Put 6 here. That brings us down to 6. And then put 6 down here. That brings us to 0. So we've got no electrons left, and that's a problem because sulfur's not happy. Sulfur's got 2, 2, and 2. It's got 6 electrons, needs 8. So what we're going to do is look at one of these oxygens and borrow a set of electrons. We'll take that set. You could have picked any oxygen and you could have picked any set of electrons. But I'll pick this one, and I'm going to turn that into a double bond. So those electrons don't belong just around this oxygen anymore. Now they go back and forth between the oxygen and the sulfur. And sulfur's got 2, 4, 6, 8. It's happy. This oxygen's happy. It's got 2, 4, 6, and then 8, the 2 in the bond. Same with this one. And down here, it's got 2, 4, and then 6, 8 in the 2 bonds. So everybody's happy. And this one turns into trigonal, because you've got 3 atoms bonded to the center one. Trigonal planar. Now, because there's no electrons here, there's a lack of electrons up here, that means that none of these guys are going to be pushed away from that negative region. They're all going to spread out equally, equidistant from each other, and we end up with this trigonal planar. CO2. Carbon's got 4, oxygen 6 times 2, that's 12. 4 plus 12 is 16 electrons. So these guys divvy up 16 electrons. Carbon goes in the middle. Here's my 2 oxygens. 16 minus 4 is 12. Give your outer guys an octet. And there goes 12 electrons. So now the bank is closed. The pool is empty. There's nothing else for carbon, and carbon is not happy. So the last step is to rearrange some of these bonds. Now carbon looks at the 2 oxygens and says, hey guys, help me out. Share another set with me. 2 sets, in fact, and now I'll have all 8. 2, 4, 6, 8, and you'll still have your 8. I'm still going to send them back to you. Now, you could have done it like this with the 2 double bonds, or you could have done a triple on one side and a single on the other. Both would have been acceptable. Or you could have flipped it around, put the triple on this side. Oops, not that. Triple on this side, and the single on the other. It doesn't matter. In reality, if you look at it forwards or backwards, it's still the same. Okay, so there's carbon dioxide. And this, by the way, is linear. When you do out the model, you look, there's no extra unshared electrons, so these guys are as far away from each other as possible. 180 degrees on the top and 180 degrees on the bottom, so this is linear. CO. Carbon's 4, oxygen 6. These 2 little guys are going to divvy up 10 electrons. So connect them. Now 10 is 8. Pick one of your favorite elements. Either carbon or oxygen, doesn't matter which, but give it a complete octet. It's already got 2, so you need to add 6 more. Oops, 8 minus 6 is 2. And then take those 2 and put them on the other guy. Now the bank is closed, and that's a problem for oxygen because it's not happy. You don't have extra electrons in the pool to just go throwing electrons on here. So what you're going to do is borrow them from carbon. Oxygen looks at carbon and says, can I borrow those also? They're going to zip around me and you. I won't keep them from you, but they're going to go back and forth. And that actually happens twice, and you end up with a triple bond in between. And this obviously is linear because the only way to hook up 2 is in a straight line. H2CO. Hydrogen's 1 times 2. There's 2. Carbon's 4. Oxygen's 6. Adds up to 12 electrons. Now, hydrogen is never in the center. Carbon usually is. So put carbon here. You could put a hydrogen here, you could put an oxygen down here. You could have done this, HHO, you could have done COHH, it doesn't matter. All of these will ultimately be the same. In any case, we use 2, 4, 6 electrons, so we're now down to 6, and then we have to give our outer guys an octet. Remember, hydrogens, they're all set with just 1 bond, so we don't want to add any more electrons on hydrogen. We do want to put them around oxygen. So 1, 2, 3, 4, 5, 6, bank is closed, there's nothing left for carbon, and that's a problem, because little carbon's got 2, 4, 6, and it needs 2 more. But there's none in the bank. So we look at oxygen and say, can you share? And oxygen says, yes, sure, as long as you send them back to me, and we end up with a double bond, and then H's. And if we look at what this looks like in reality, it's trigonal planar. We have 3 atoms bonded to the center one, and there's no unshared electrons, so they don't get bent away from that region. They all spread out evenly, so the same distance between each one of those atoms occurs, and it says trigonal planar. It's on the same plane. Ozone. Oxygen times 3 is 18. oxygen says there's no metals, let's do it ourselves. Let's share enough electrons, pool them all together, divvy them up, and share them so we all get stable. So 18 minus the 4 gives us 14. 6 there. Now we're down to 8. 6 there. Now we're down to 2. And then finally, put the 2 on the top. There's nothing left in the bank, and that's not a good thing for oxygen because oxygen's only got 6. So eeny, meeny, miny, mo, pick your favorite oxygen. We'll go here, double it up, and now you have a double bond. And you could have put the double bond on this side like we did, or you could have put it on the other side. Now polyatomics, the charge here is going to be our kind of adjustment factor. We're going to add up our electrons, like carbon contributes 4, nitrogen contributes 5. That's 9 electrons. We can't deal with 9 because everything needs to be in pairs. A bond is 2, a set of electrons is 2. What are we going to do with an odd number? So we need this charge to adjust it. Now remember, -1 means 1 more electron. So we're going to take our 9 and turn it into 10. So now C and N are going to share 10 electrons. 10 minus 2 for the first bond is 8. Pick your favorite element, give it a full octet. Now we're down to 2, put the 2 there, and then you realize the bank is closed and nitrogen's not happy, so it hooks up with, or it borrows from the carbon and makes a triple bond. Now the catch is with polyatomics, you've got to put these guys in brackets and put its official charge, formal charge, out front. So that's what it should look like. Ammonium, here's 5, here's 4, and that's 9. That's a problem. But instead of adding 1 more electron and getting up to 10, this means we remove. Remember, we're going to have 1 more positive. So we lose an electron, so we have 8, which actually works out perfect, because watch this. There's NH4, and then you count 2, 2, 2, and 2, 2, 4, 6, 8. Bank is closed, and everybody's happy. So just put this in brackets to indicate that it normally wouldn't bond unless you remove an electron. And finally, nitrate. Nitrogen's got 5, oxygen 6 times 3, that's 18. Add them up, you get 23. Right away, that's a problem. But thank goodness we have a charge. We're going to add 1 more electron, and that turns into 24. So nitrogen, oxygen, oxygen, oxygen. There's 6, 18. Give your outer guys an octet. 6 there, 6 there, and 6 there. 6 and 6 and 6 is 18. Bank is empty, which is not a good thing for nitrogen. Nitrogen's looking and saying, I have 6, I need 8. Somebody want to give me 2 more? So eeny, meeny, miny, mo, pick a set and turn it into a double bond. This is now written correctly. And this, by the way, the shape, because there's no unshared electrons, it's trigonal planar. You have the nitrogen in the center, and then these oxygens spread out as far away from each other as they can. This, by the way, I forgot to tell you, was tetrahedral. These guys spread out as far away from each other as they can, about 109.5 degrees in between them. And this one is just linear, because the only way you can hook up 2 atoms is in a straight line. All right, so practice those, and look at your handouts, review those, and get yourself ready for the quizzes and tests.